This is ACT Math Prep video number 5. You will have 6 minutes for 8 questions. So as usual, set a timer for 8 minutes, pause the video. At the conclusion of those 8 minutes, restart the video. Number 51, we have an equilateral triangle, which means all sides are the same length, in this case 6, and all angles are the same measure. Triangles, the sum of the angles is 180, which would leave each angle being 60 degrees. We are looking for the height of the triangle. Okay, so when I draw the height, I cut the bottom in half, which leaves this 3. If you remember your relationships for the 30, 60, 90 triangles, because that's what this is, we've got a 60 here, 60 that got cut in half up here, so 30, 60, 90. Makes this one really easy because you're looking for the long side. And hopefully you remember from geometry and or algebra 2 that for the 30, 60, 90, it's all dependent upon the short side, the hypotenuse of which is twice the short side, which jives over here. We've got a short side of 3, a hypotenuse which is double. They're in a 2-to-1 relationship. And then the long side is short root 3. That's something worth memorizing because what it does is it allows me to get this really quickly without any work. But for the review videos, you always I want to give you a backup plan in case you forget that. At a bare minimum, you should remember your Pythagorean theorem. So if you forgot the 30, 60, 90, you can always default to a squared plus b squared equals c squared. So you'd have 9 plus x squared is equal to 36. Subtract the 9. Again, this is longer, but if you forget that 30, 60, 90, you should at least remember your Pythagorean theorem. Square root of 27, its perfect square, hiding in it is a 9, which leads us to 3 root 3, a much longer route. So it's best if you can remember those relationships, but if not, you can default on the Pythagorean theorem. Next up, number 52. What is the measurement of one interior angle in a regular octagon? A regular polygon has all angles congruent and all sides congruent. A regular octagon would have 8 of those, looking kind of like a stop sign. So all of these angles are the same measure. I'm looking for the measure of one of them. To find the measure of one of them, I need to know what they all add up to. And there's a formula for it, but maybe you forgot that from geometry. I'll put it on here, but you take the number of angles minus 2, or number of sides minus 2, times 180, and that gives you what they all add up to. So that would give you what? X plus X plus X plus X plus X plus X plus X, what all of those add up to. I don't want to know that, though. I want to know what one of them is. So there's to be shared equally amongst all n, in this case 8, angles. So if I apply that formula to this problem, n being 8 because it's an octagon, I'd have 8 minus 2, which is 6, times 180 degrees, divided up amongst the 8 angles, and I'll get 135. This is a formula a lot of people forget, and in the event that you forget it, kind of think of, I want you to see where it comes from, and again, I'm going to take a little time to explain things on these videos. Not as much as I'd like to, but as much as I can. So, where does that formula come from? I'm going to show you with a square. A regular quadrilateral has 4 sides. It can be divided into 2 triangles, and each triangle has a sum of 180 degrees. So there's 360 degrees in that square. A pentagon, which has 5 sides, can be divided into 3 triangles, each measuring 180 degrees inside. So you'll notice that this is 4 minus 2, 5 minus 2. This was 8 minus 2. If we want to know what just one of those angles is, we divide it by how many there are. So each one of those would be 5. So you can kind of see where that comes from. There's always 2 fewer triangles. Even if I go back to my octagon, 8 sides, I draw from a vertex here. If I draw all the triangles, you notice there's 1, 2, 3, 4, 5, 6 of them. That's where this n minus 2 comes in. Every triangle, its angles add up to 180. And so when I kind of go through and make all of these, what I'll end up with is the angles in the entire octagon. All right, next one up. Lots of geometry, that's what we're reviewing in these middle videos. A spherical ball has a diameter of 12 and is submerged in a cylindrical can that's completely filled with water. So we've got a can that's 30 centimeters tall. Let's go draw that. The can has a radius of 9. Got a little carried away there. The can has a radius of 9. There's a ball going into it that has a radius of 6. So I'm going to draw a little ball in here. A radius of 6. That's not the best picture. But it says how much water is left in the can when the ball is removed. Well, the volume of the ball will be the volume of the water that spills out. So what I really need to do with this one is find the volume of the ball, which will equal the volume of the water that gets spilled out. It's displacement theory. The volume is given to you for the sphere. It's 4/3 times pi times the radius cubed. The radius of the ball on this one is 6, so 6 cubed. And again, if you look at these answers, they all have the pi in them, so don't put that on your calculator. Go do the rest of it. And what you'll get when you do that is 288 pi. So the volume of the ball is the volume of the water that spills out. The volume of a cylinder, that's one that they didn't give you. It's expected you know that. It's the area of the base, pi r squared, and then you fill it up with that height, which in this case was 30. It's pi r squared h. Volume of any right prism, though, you cover the bottom and fill it up. Pi r squared h, and again, leaving it in terms of pi, my radius on that one was what, 9, I believe? Yep, 9 squared. So leave the pi in your answer and you'll get 2,430 pi. If I subtract these, I'll get how much water is left in the can, the cylinder, minus the spill, which will give me that one if I subtract correctly. Number 54, I have to figure out what the measure of EC is. So I'm going to go put a little X on that. My problem with this, actually I'm not going to put an X on, I'm going to leave that undone. You need to know, again, this is geometry section, so all these have to do with remembering all your geometry stuff, that you have two triangles up here. You have this big one on the outside in blue, and then you also have this little one on the inside in red. And they are similar, which means the ratios of the sides are the same. So you'll notice that the one you're looking for from E to C, that's not even a leg of any of those triangles. However, this is. So if I can find from A to F, and if I do 9 minus it, I'll have what's left over there. So I'm going to set up some ratios of sides. This is what I've got going. I've got the right-hand side of the small red is to the right-hand side of the big blue. It's these. In exactly the same proportion as, now I'm done on the bottom of the small one is to the bottom of the big one. When I solve this by cross multiplying, that's how we solve all proportions, I get that x is 6, which tempts me to circle C, but I always keep that question in mind. I like to put a question mark on what I'm finding. I did not find question mark. Question mark would be 9 minus 6, which gives me 3. Moving right along here to number 55. Circular pizza with a diameter of 16. Most things require the radius, not the diameter, so I'm going to go like, there's your pizza. It's cut into 8 equal slices. Pictures are worth 1,000 words here, so let's go slice that pizza up. They're all exactly the same area. You're going to take 3 slices and eat them. Let's suppose you eat these 3. And you want to find the area of the remaining. So area of these 5 slices. Well, if I could get the area of one of the slices, multiply it by 5, I'd have it. Well, here's the whole pizza. Pi times radius squared. Again, if you're debating between 2 pi r and pi r squared, area is always labeled like feet squared, inches squared, so area has the squaring in it. This is circumference, distance around. That would be the distance around the crust. It's not what I want. Again, notice that that pi is still in my answer, so I'm only going to do the 8 squared. I'm going to leave the pi on there. That's the whole dang thing. It was chopped into 8 equal pieces, which gives me 8 pi for each slice. I'm going to write this, each slice, 8 pi. I ate 3 of them, or 24 pi, and I didn't eat 5 of them, or 40 pi. And it says, what is the remaining? So it'd be B. And last but not least, number 56. Before I discuss number 56, there's 2 general theorems with tangents to a circle that you might be asked about. One has to do with the picture like this, where you've got 2 tangents drawn from the same point, and you are to deduce that these tangents are congruent. That's true. Another thing that you might be asked, or see, is that a tangent drawn to a point of tangency on the circle, when you connect the radius to it, it's always 90 degrees. That's not going to happen here because I didn't hit the center, but again, the ACT can't ask you everything, it just asks you some things, but you may very well need to know this relationship also. It says on this one that I've got angle Z up there being 50 degrees, and I'm looking for XWZ. Well, if I knew this one, I'd have it, because I know in a triangle they have to add up to 180, but unfortunately, they didn't give me that. So what I need to know is that these are the same. And in a triangle, when those legs are the same, it creates what we call an isosceles triangle. And again, from geometry, you have to remember that not only are those legs of equal length, but the base angles are of equal measure. So now I can go figure that out, because I've got the 180 in the triangle minus the 50 up at Z. I've got 130 degrees for these 2 to share. If I didn't know it was isosceles, I'd be stuck. But because it's isosceles and these base angles are equal, I have to take that 130 and split it equally among those 2 base angles, which gives me C, or 65 degrees, as my answer. And that's the 12-minute discussion for this video.